That's Sally here. Kayla. Mason here. Jaylianne. Valerie. Katie. Dakota. Dawson here. Olivia. Olivia. Let me see if I have an email. No. Nate's here. Mary here. Mandy here. Change your hair. Sharon here. Austin is going to be excused this week. And that's it. All right. I tried to bring you the Florida weather, guys. I was in Florida for Thursday to Sunday. Looks like our Wednesday is going to be like that. All right, let's remember what we did last time. Okay. We developed the basics of the capital asset pricing model. Let's just remember what that says. Or CAPM. It basically says for any asset or any portfolio, obviously a single asset is also a trivial portfolio. We should have expected value of return to that portfolio minus the risk-free rate should equal some beta of that portfolio times MRP, where MRP is excess return to or reward to market portfolio. And this beta, let's make that Greek letter. In a sense, it says the reward, and what we mean by reward or risk premium for any portfolio is proportional to the market risk premium. Okay, and that proportionality is measured by the beta, where beta is essentially a measure of how sensitive the portfolio is to the systematic or market risk. Technically speaking, the model says how sensitive it is to the market risk, but capital asset pricing model assumes that there is only one type of systematic risk, and that's the market risk. And that's why systematic or market risk. Now, this says another way of thinking about this is instead of expected returns, the excess return to a portfolio should be equal to beta times return to the market portfolio minus the risk-free rate. Plus a random term where UP is a random term that is not correlated with the observed market risk premium. Have you guys been exposed to basic linear regression in your stats classes? Well, basic linear regression, a simple linear regression is a statistical model where a dependent variable, say y, is expressed as a function of a linear function of an independent variable and an error term. So y, let's call that yt for time, is equal to some alpha plus beta times xt plus some ut. Where ut is a random error term that is not correlated with xt or the independent variable. If you had data on both y and x, there are statistical methods that's going to allow us to have estimates of alpha and beta. If you had data on yt and xt, we can estimate values for the intercept coefficient which is alpha, and the slope coefficient intercept coefficient alpha and slope coefficient beta. Okay. Now, We have statistical ways, methods to estimate it, and we're going to use Excel to do it. That's the easy part. Let's think about what this equation says. This basically says if my YT, or dependent variable, was equal to risk premium for a given portfolio, which is the return on that portfolio minus the risk-free rate, uh, and the X variable is the market risk premium, return on the market portfolio minus the risk-free rate. If I estimated alpha and beta, I should get alpha that is, precisely equal to 0. Using data, it will never be equal to 0, but it should be pretty close to 0. Hence, CAPM says that if YT is equal to return, I'm going to call this RPT, return on the portfolio minus the risk-free rate, and XT is return on the market portfolio minus the risk-free rate. Estimates of alpha, should be very close to 0. That's the first implication of CAPM. If we were ever to test CAPM as a theory of asset pricing, any portfolio of assets, whether the single stocks or any portfolio, estimated value of the alpha should be very close to 0, and we also should have the following ratio, which is, if I don't misremember, known as the Trainer ratio.